Now let us solve another question which is based on pipelining, which was given in GATE 2015 for 2 marks. Here it goes. Consider a non-pipeline processor with a clock rate of 2.5 GHz and average cycles per instruction of 4. The same processor is upgraded to a pipeline processor with 5 stages, but due to the internal pipeline delay, the clock speed is reduced to 2 GHz. Assume that there are no stall cycles in the pipeline. The speed up achieved in this pipeline processor is what? Just have a look at this question. A non-pipeline processor with a clock rate of 2.5 GHz. Let us put it this way. Let us consolidate the data. That is non-pipeline system. Non-pipeline processor. Clock rate is equal to 2.5 GHz. Clock frequency is equal to 2.5 GHz. When it comes to pipeline processor, clock frequency is equal to 2 GHz. Okay. Here, average cycles per instruction of 4. In a non-pipeline processor, one instruction takes 4 clock cycles. Okay. But in a pipeline system, one instruction takes only 1 clock cycle. You know that? In a pipeline system, one instruction is just 1 clock cycle on an average. Okay, this is for pipeline. We are asked the speed up ratio between non-pipeline system and a pipeline system. Okay, so the speed up will be equal to non-pipeline system time. Non-pipeline system time is equal to 4 clock cycles. 4 into, I need to put the clock cycles here. 4 clock cycles, which is depending on the clock rate. Pipeline system is 1 into clock cycles. That is equal to, in a non-pipeline system, 4 into clock rate is equal to 2.5, right? The clock rate is equal to 2.5. So that is 4 into T is equal to 1 by F, right? 4 into the clock cycle. The clock cycles are mentioned in frequency, but we need to convert it into time. The speed up is a time ratio, right? So that is 4 into 1 clock cycle is equal to 1 by 2.5, because time is equal to 1 by frequency. Here 1 into 1 by 2, because the frequency of the pipeline processor is equal to 2. So that is 4 by 2.5 divided by 1 by 2, which is equal to 8 by 2.5. That is equal to 3.2. This is the answer. Speed up is equal to the number of clock cycles that are required for one instruction in a non-pipeline processor, the number of clock cycles that are required for one instruction in the pipeline processor. This 4 must be multiplied with the clock rate. The clock rate is given in frequency. Frequency is 1 by T, right? So 4 into 1 by 2.5, 1 into 1 by 2. That is equal to 8 by 2.5. That is equal to 3.2 is the correct option and answer.